So today's title is called Simplifying Fractions. Today, by the end of this lesson, you'll be able to simplify and compare fractions. So first off, we're going to do a quick review of the identity property of multiplication. Basically, we take any number, we multiply it 1, it'll give us that same exact number. So if I did 2. 2 times 1 is going to give me 2. Or 5 times 1 is going to give me 5. 20 times 1 is going to give me 20. So any number times it by 1, we get the same exact number. So make sure that's in your notes. So I'm going to give the example of fractions. So I have 2/3 times 1 is equal to 2/3. So go ahead and put that in your notes. This is going to be your fraction example. Same exact thing. We're multiplying it by 1, getting the same exact number that we started with. But with fractions, there's a little hiccup. Or not a little hiccup, but little interesting thing about it. We're multiplying by 1, but there's actually different types of forms of 1. Now what are you talking about? So we're dealing with 1. Remember, fractions, if it's the same whole number over one another, it's equal to 1. So we can have 2 over 2, or 3 over 3, or 4 over 4, 5 over 5. We can keep going all the way to 23 over 23. So I want this in your notes, and this is how we're doing it. So we have 1, right? So think of a whole circle totally filled in. If we take our circle and we cut it in half, basically I've filled it in. So I still technically have a whole circle, but I'm just rewriting it. So we're just manipulating. So make sure all the different forms are in your notes. So technically, there's an infinite number of ways we can write a fraction. So what do I mean by writing this fraction? So let's say, for example, we take our 2/3. Now, we can multiply it 2 over 2, which will give me 4 over 6, or we can write 2 over 3 times 3, and that will give me 6 over 9. And if you notice, ladies and gentlemen, we haven't technically changed the value. So 6 over 9 is still the same exact value as 4 over 6, which is the same exact value as 2/3. We're dealing with the same exact fraction, but it's just in a different, different form. It's just in a different form. We can just keep multiplying it by it. So then if I take my 2/3 and I multiply it by 4, I get 8 over 12, which is also another version of 2/3. So I can just keep going on and on and on if I want to, taking different numbers. So the big thing I want you to take from fractions is that there are many forms of 1. We can rewrite it any way we want. We're still going to end up with the same exact number that we started with. Why? Because our 1 value, we're manipulating. So make sure everything that's on this page, everything is in your notes. So for right now, just watch. So I've given you a model. Now if we look at this model, I have I have 3 pieces, right? So it's out of 3 pieces. But my question to you is, how many pieces are colored? Well, this side is colored, so that's 1 piece. That side is colored, 2 pieces. So how many pieces are colored? 2/3 of my model is colored. So that's where I get 2/3 from. Now, if I were to times it by 2, and I break it apart, look what happens. So I'm manipulating. So let's count. Let's say I have 1, 2, 3, 4, 5, 6 pieces now. So 6 pieces, but let's see how many are shaded in. 1, 2, 3, 4. So I have 4 over 6. If we multiply this, what's 2 times 2? 4. 2 times 3 is 6. So these 2 shapes are actually the exact same thing. All we did was manipulate it. We started with 3 pieces over here, now we have 6 pieces over here. All we're doing is manipulating. Equivalent. Equivalent means the same thing. So that's how we get our 4/6. Now, let's take our 2/3 and let's see if we multiplied it by 3. So let's see what happens to our model. Let's count our pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 pieces. 1 piece is colored, 2, 3, 4, 5, 6. So 6 out of my 9 pieces are colored. So technically, these are exactly the same. Once again, they're equivalent. All I did was change form. We're manipulating. We're just changing the form. Not changing the value, just changing the form. And that's how I got 6/9. So in your notes, go and write down the directions. What we're going to do is find 3 equivalent fractions to the fraction below. Now there's many different answers, but watch and see what my answers are going to be. So we're going to take our 3/5, we're going to multiply it by 2. So it's 3 times 2, 6. 5 times 2 is 10. So it's one of our equivalent fractions. Then I'm going to multiply it, both of them, by 3. Then I end up getting 9/15, which is another equivalent fraction. I need one more, so I'm going to pick 4, multiply it by 4, and I get 12/20, which is another equivalent fraction. So that's what we're doing. You're making sure you're multiplying by the same number in the numerator and the denominator in order to get our equivalent fraction. Technically, all these fractions are exactly the same, just like before. We're changing the pieces. So before, let's see. Oh, okay, I can't draw, but we started with 5 pieces, we ended with 20 pieces, but they're still equivalent, they're the same, we're just kind of manipulating them. One thing I want to notice though is 3/5 is most simplified. It's going to ask you to simplify it. We want to get it down to the smallest form. Simplified is the smallest form. That is what we're looking for though. So, in your notes, write down the direction, write down the directions, and then go ahead and see what you come up for equivalent fraction for 1/5. Let's see what we get for number 1. Now, there are lots of different answers, so I'm starting with the easy one, 2. So let's do 1/5, so 2/2. That gives me 2/10, so this should be equal to 2/10. And then let's pick some random number. I pick 1/5. Let's just do 5. This will give me 5/25. So as long as you're multiplying the original fraction by the same numerator and denominator, you're going to get an equivalent fraction. And if they want me to circle the most simplified form, would I circle? I always circle the first form, because I'm looking for the smallest form. Smallest, easiest numbers. So now, let's see what you come up with for number 2. So as long as you do your math right, you can pick any number. So let's see, I'm going to do 3/7. I'm going to multiply this one by 3. So I get 9/21. And let's do 3/7. Let's pick 7. And I get 21/49. Once again, they're still all equivalent because I'm multiplying the same exact fraction just by 1. And if I have to circle the most simplified, well, it's our original because we're always looking for the smallest form. Now, go and write down our directions as well as our new vocab word, simplest form. So basically, simplest form is when the numerator and the denominator have no common factors other than 1. So for example, 2/3 is in the simplest form. Why? Because the only way we can do it is dividing 1 by both of them to get me 2/3. Now a non-example would be 2/4. Why? Because we have a common factor. Well, what's our common factor? Common factor is 2. So if I divide 2 on both of them, I'd get 1/2. Now 1/2 is my simplest form. So be very careful. No other number besides 1. So this was a non-example. This was not simplest form. That was wrong. I'd simplify it first in order to get my simplest form. Once you have that all written down, we're going to try to do number 1 and see what we come up with. And remember, take a look at our hint. What is our hint asking us to do? So my hint is telling me, let's try to find the greatest common factor. So if I do a quick little chart of 12 and 48. Now looking at 12, I think of 2 and 6, 4 and 3. Nothing else doesn't work. Now let's see. 48, let's see, 2, oh, let's try a different color. 2 and 24. Well, 3 will go into it. Let's see, 3 divides into 48. 1, 3, 16 times. See, 4 will go into it 12 times. And of course 6 and 8. I think that's almost all of my factors. And if I take a look, hey, they both have 6 in common. So in order to simplify, I can divide both sides by 6. Because remember, this is technically 6 divided by 6 is equal to 1. So we're just manipulating a fraction. And if I simplify, I end up getting 2 over 8. Oh, ladies and gentlemen, I messed up that cardinal rule. Remember, 1 and 12. I forgot my 1. So actually, I made that mistake. It's actually supposed to be 12 is our greatest common factor. So that's why it really pays, ladies and gentlemen, to make sure you add that 1 in there. So let's try this one more time. So we should be dividing by 12 on both sides. I'm sorry, in the numerator and the denominator. I end up with, what's 12 divided by 12? 1. 48 divided by 12 is 2. So 2 would be my simplest form. Now let's say you didn't find the greatest common factor. Let's say you want to do it the long way. Watch what happens if you try to do it the long way. If I do 12 divided by 48, so let's see. When I look at 12 and 48, I automatically think of 2. So let's divide this by 2. Divide this by 2, and I get 6 over 24. And then let's see, between 6 and 24, well, I know 6 is a multiple of 24, so then I can divide this by 6, divide this by 6, and I end up, let's see, 1 over 4. Did I mess up on my math somewhere? I did, ladies and gentlemen, up here. This is what happens, ladies and gentlemen, when you try to do the shortcuts in your head. Sometimes you don't do the math quite right. So, as some of you probably already pointed out, 12 divided into 48 is actually 4. It goes into 4 times. So, we get the same exact answer, except this took a lot longer. So it's up to you. Either you can find the greatest common factor, which you simplify only once, or sometimes if you do 1 step and then 2 steps to get your answer. Now, on your own, go ahead and try to solve number 2. What do you think the greatest common factor is going to be for 3 and 9? Now this one was a little bit easier, because you should notice, between 3 and 9, there's not that many factors. So we have 1 and 3, 1 and 9, 3 and 3, and there we go, bingo. We have a 3 in common. So divide numerator by 3, divide the denominator by 3, and I end up getting 1 over 3, which is going to be my simplest form. So that's it. Make sure you're dividing by the same exact value. That's the only way we can find the equivalent fraction as we're simplifying it. Now don't panic just because we're using variables. I'm going to show you how to solve this. So make sure you have the directions and go write down example number 1. Now, how do we simplify this? So first off, like I taught you yesterday, let's expand it. So our numerator is technically 2 times x. Denominator is 3 times x. Now, is there anything we can simplify that looks the same that we can get rid of? If you notice, I both have an x right here. So if I imagine those x's, let's say those x's were 4 over 4. Can I simplify those down? Yes, I can. I can simplify them down where they equal to just 1. So let's see what happens. Since they're both the same exact value, I can cancel them out, and then what do I have left over? All I have left over is my 2/3. So 2/3 is going to be my answer. Now, go right down number 2. Let's see how we're going to solve number 2. Number 2 is a little trickier. We have constants and we have some variables. So let's expand this out. So first off, we have 8 times p times r all over 12 and a p. Now let's try to figure out our, oops, forgot my multiplication sign. Let's try to figure out our 8 and 12 first. I like to find the greatest common factor. It makes life a little bit easier. So between 8 and 12, what do we have? We have 1 and 8, 2 and 4, okay, 1 and 12, 2 and 6, 3 and 4. So it looks like 4 is going to be a greatest common factor. So if I divide my 8 by 4, and if I divide my 12 by 4, what do I have left over? I have 2/3, which we already know is in our simplest form. Now, don't forget about your variables though. So what are we going to do with our variables? Does anything look the same? Yes, something does. What looks the same? Our p's. So I can cancel out my p's, and what do I have left over? My r. So my r follows along, it becomes 2r, and that is going to be my answer. You guys know how to simplify. Look for what's the same and cancel them out. Now, on your own, go ahead and try to do number 3. What is this going to look like? So, for number 3, I hope you expanded everything out. I have an x squared. Remember, x squared is technically equal to x times x. So let's just go and expand everything out. So I have x times what? I have it left over y, all over 3 times y times z. So let's take a look. Do I have any x's in common? No. So that means my x's are just going to follow along. Do I have any y's in common? I do have some y's in common, so I can cancel out those y's. Let's take a look. So there's nothing else in the numerator. Look at the denominator. I have my 3, and I have my z, but there's something wrong with my x's. I want them to look nicer. So my answer is actually going to end up being, what do my x's need to be? I can turn it back into an exponent. So it actually ends up being x squared all over 3z, and that is going to be my simplified form. That's my answer. Oops. So grant me a 2-sentence summary. In your summary, you should mention, I should really do long division, make sure to check my math, but what else did we learn today? We learned how to simplify a fraction, equivalent fractions. Two-sentence summary. What did we learn?